All right, on the next page here, you'll see a very iconic component in the nuclear industry, and this is a natural draft cooling tower. And this is just a general discussion on a cooling tower. But here, this is really cool. There is no forced circulation. What happens is we'll generally use these for circulating water in a closed system. And the hot circulating water will actually be injected into this cooling tower with a warm water distribution header up here, and it'll spray downward. And this is an air-to-water heat exchange. So the hot air will tend to rise up, so it's less dense. And the colder air out here is falling, and it's going to be going in this direction. And the hot, moist air with some steam is going to actually come out the top. Very, very expensive, these cooling towers. No moving components or anything. The hot water, the warm water distribution up here, it is, they increase the surface area using a fill material, which is generally some sort of plastic. And you can see the flow path here, and then you saw the outlet, the cool water ends up being the suction source for circ water intake pumps. So they're pretty cool, very expensive. Last sentence on the right here, the natural convection cooling towers like this are much larger than forced draft cooling towers, and they are expensive to construct. So when we talk about forced draft, you come to the next page, and we actually see forced draft. We actually have a fan up here. Now this is generally going to be several large fans, and I may see a row of these, looking like this, where here's 1 and 2 and 3 and 4 and 5 and 6 and 7, and there's fans in each one of these. Fans in each one. And these would be cells. So the water would be down here, and that's how you see this picture right here. And you see the water is coming down, getting cooled, and air is brought in via the suction side of this fan, and this cool air comes in, and the warm air with the water coming down from the warm water distribution or injection system up here, that warm water goes down to the fill, and it is once again an air to water heat exchange, and the warm air then is going to be going that way, and the cool air will be coming this way to cool the water. Now very often when we're re-injecting our circ water back into a river for thermal pollution's sake, we'll use this type of cooling tower prior to returning the water back to the river to minimize our thermal pollution. So very similar to the natural draft, except that I actually have an electric fan. Very often this fan is a variable pitch blades, and setting them up can be a little difficult during construction, but pretty simple design actually.